Hello, and welcome to today's ACM SIGSOFT webinar. This webcast is part of ACM SIGSOFT's commitment to provide value to its current and future members. The ACM SIGSOFT webinar series features speakers from the Future of Software Engineering track at the International Conference on Software Engineering, as well as select keynote speakers and distinguished paper authors. I am David Budgeon. I'm a professor at the University of Durham in the UK, and it is my pleasure to welcome you today. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows, Command-R on a Mac, or refresh your browser on mobile devices. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during this webinar, please type them into the question and answer box at any time during the webinar and click the Submit button. At the end of the presentation, we will have time to respond to questions. This session is being recorded and will be archived. Automatic email notification when it becomes available. Today's presentation is What Makes Expert Software Designers Successful? By André van der Hoek. André is a programmer at heart who thrives on talking to and working with software designers and developers to create new tools that help them to be more effective and efficient. He is a professor of informatics at the University of California, Irvine, where he heads the Software Design and Collaboration Laboratory. André is co-author with Marion Petre of the book Software Design Decoded, 66 Ways How Experts Think, and co-editor with Marion Petre of the book Studying Professional Software Design, a Human-Centric Look at Design Work. So André, without further ado, over to you.
Thank you so much, David. It's an honor to be here. Good day to everybody. And again, thank you to David for the lovely intro and agreeing to be the host today. I'm looking forward to sharing with you all some of the things that I've learned about expert software designers and what makes them successful. This is not my sole work. This is work that I did together with Marion Petre at the Open University. So a quick shout out. I know that she's listening. And while she's not here in Irvine with me, otherwise we would have actually done the talk together, let this presentation be on behalf of both of us. So let me get started. And I always like to introduce myself a little bit. I'm from the Netherlands. I was born and raised there. I had the wonderful opportunity to go to Boulder, Colorado. That's the picture that's in front of you. For 1 year as an undergraduate student, as an exchange student. Landed there, and of course you see the mountains. And I'm an avid cyclist, so I enjoyed it there. And before you know it, I was actually ended up being a PhD student at the University of Colorado. Of course, being from the Netherlands, I kept cycling, not always successful. As you can tell in this particular picture, the bicycle path is on the other side of the tree. And if the picture had been taken a little bit earlier, I would have been upside down because I actually made a full flip. But I also actually engaged in research, working with my advisor there, Professor Alex Wolf, who many of you will know as one of the key figures in the ACM for quite some time, and did my PhD in software engineering and specifically software configuration management. So did that, then ended up at an interesting place. I ended up at the Department of Informatics at the University of California, Irvine. And in this department, we don't only have computer scientists, we have anthropologists, we have humanists, we have lawyers, we have psychologists, and a whole bunch of people, colleagues and faculty and students who come to the discipline from many different directions. And what we do is we end up not just, like I do, build tools, but actually also study how people work and how people actually engage with technology. And so I like to say that I was positively corrupted by my colleagues there, because whereas I used to build my tools, publish them, declare them really good, they corrupted me into actually really understanding what software developers do, how they work, and sort of slowly but surely broadened my research agenda to not just be about tool building, but also be about understanding and then trying to build tools that actually work hand in hand with how developers work. So my research areas are collaboration. I still make a nod to configuration management and how software development teams work together. Design. Clearly, that's become a huge interest of me in terms of trying to figure out how do we actually design and how can we do that better. And then I like to bring a lot of that into education, into the classroom and into the teaching of the students. And that's probably where most of today's talk in some ways got its inspiration, because I was always teaching a software engineering class like we always do, and there's a requirements engineering part. And you teach them about the requirements document, and then you teach them about UML, and you say, now go home and come back with a good design. But what I didn't have was the actual material to tell them how they should engage in design. And that is where the inspiration for this project started to come from, is what do designers do? How can we look at them? And so before I dive deeply into that, here's just some example projects that I've engaged in over the many years. From the top row that talks a lot about configuration management and collaboration, where we looked at, in the middle top rows, for instance, how different developers were working in parallel on different files, and we could visualize that and see the conflicts emerge, to below that, Lighthouse being a tool that actually did advanced warnings of potential conflicts that might arise, to on the bottom right, Calico, which is a tool that helps software designers by sketching. So much of my work is still driven by tools, but is now actually informed by understanding more how people work. And that gets me to the topic today. Okay, so when we talk about software engineering today, there's many neat terms that are out there. We talk about artificial intelligence, we talk about big data or data science, blockchain is exciting, green information technology, sustainability, still important, natural language processing, and security. Those are the topics that browse around on the internet today, and that's where our space of software development is currently. But not too long ago, there was a different set of terms. Not that different, but still they were different. Right? We talked about cloud computing. That was the hot thing. Or the IoT, or microservices, or multi-core software development, or virtual reality and web services. And if we go back in time more, we talked about browser-based computing and mashups and grid computing, and open source was just becoming important, and open and component-based software development. And so clearly, and not surprisingly, the kinds of topics that are current and that we talk about change. And that is normal to a field like ours. But when we think about it, and especially when we think about software design and software development, a key observation to make is that in a landscape where technologies and infrastructures change orders of magnitude faster than personnel, one thing remains of constant importance, right? The ability of software developers to be great designers. We can't, when we switch from, let's say, NLP to AI, or from AI to blockchain, we can't sort of fire all our developers and say, we'll hire a new bunch that all know this new technology, because 2 months from now there might be a new technology and we fire all our developers again and come back. So something is happening that says as an organization, I need to pay really a lot of attention to the ability of my developers, not just to be programmers, but actually to be great designers. So normally in a talk like this, I will now go to the audience and say, so what exactly sets expert designers apart, right? So how do we know that we have an expert designer, and how do they behave? What do they do? And what allows them to have sort of this success, regardless of the technology or infrastructure du jour? And almost every organization has a number of such folks. They are the go-to person. They are the person that we ask, look, we have a design problem. Will you work on it with us? Will you lead this particular team? And typically the answers that I might get are they're creative, or they understand the problem domain, or they're not afraid to engage with the design problem. And those are all right, but when you start thinking about how do I really now specify and figure out what they do, there's actually something underneath there. And that is what today's talk really is about. And so how do we get to that list? How do we get to understanding what designers actually do, what these great expert software designers actually do? Well, we did a number of things. And I say we because Marion and others as well were engaged in this process, of course. So one is we had lots of conversations. So we talked to actual software architects, software designers at organizations. Any opportunity that we got, we would simply ask questions. So how do you go about your work? What do you do? What happens when life is a little bit more difficult? Can you tell us a story about a particularly difficult design problem and how you got past it? And so we had a lot of conversations that started seeding some of the ideas that we talked about. We also did structured interviews, so not just sort of happenstance, but much more purposeful, constructed. And so here's one example. There's a paper called UML in Practice by Marion, which looked at what are the practices of expert software designers and expert teams surrounding UML. How much do we use it? How much do we not use it? How much does it inspire what we do? And et cetera. We also did observations. Where we actually went into the organizations and looked at how these developers actually engaged with work. So we would sit there, be a fly on the wall, and then, of course, afterwards talk to them, but try to figure out what's going on, what's happening. We also did empirical studies. In this particular case, the book captures a set of laboratory studies where what we did was we gave whom we knew were expert software designers. So we approached companies, we asked them for their best designers, we got access to them, and we gave them a design problem, and they started working on it. And we videotaped it and then dissected everything that they did from second to second to second. And we were not the only ones. We put these videos in the public domain. There's lots of others who've looked at this and from all sorts of different angles. And this particular book, Software Designers in Action, captures some of those analyses. And then, of course, we certainly did literature study. So we're not the only ones interested in this work. There's lots and lots of colleagues who are chipping away at this problem of understanding what software designers do. And so putting all of that together, Marion and I have compiled a very small little book, which I looked at yesterday, intentionally cheap. It's $9.71, at least for me, on Amazon. But, in the area of big data, it might be different for others, but nonetheless. And in this book, what we tried to capture was all of the things that we observed and that others observed that we can actually draw back to published work. So there's lots of statements about what individual expert software designers do and lots of observations. This book captures, in a very tidy way, an image, a title, and one short paragraph, 66 ways that we know experts actually think and navigate design problems. And what I'm going to do in pretty much the remainder of the talk is to actually simply go through a number of examples of the kinds of things that we've seen, with most often a little story attached to it. And then sort of wrap it up at the end and say, what does that actually mean for all of us who are engaged in software design practice? So the book has 11 themes. Keep it simple. That's not a surprise. We've heard that one before, and indeed we've heard many of these before. But the important part, as I said, is later when I bring it all back together. They collaborate. Experts are not afraid to work with others. They borrow ideas as much as they possibly can. They break the rules, etc. So there's these 11 categories. I won't go through all of them. Neither will I go through all 66 lessons. But I've actually taken a selection that I think are interesting and that allow us to say, okay, so what are maybe some of the differences between these expert software designers and how a novice might work? And so here's the first one that I want to highlight. And it's called experts focus on the essence. And so when you think about a design problem, experts are often acutely aware of where the hard part of that problem is. What is the thing that I really need to understand and I really, really need to solve before I can sort of solve the rest? And I'm going to contrast that a little bit with some of my past students in some of my past classes who I would consider novices. When I give them a design problem, sometimes the very first page of the design document says, and here's the login screen. And then the second page says, and here's the preferences screen. And they've actually gone about their design process in that way. They've had to chip away at all the peripheral things, whereas the expert will say, that's not important right now. What we need to work on is really understanding what the hard part is and why. And so here's an example taken from one of our studies. What you're looking at is two of the architects of Adobe Illustrator who were kind enough to participate in this. We gave them the design problem. We gave them the whiteboard. They read the prompt for a while, started working, and then you can see the left hand of the person on the left. It's actually just the left finger, and it's pointing to one part. And in the larger box, it says COP. And so the design problem that we gave them was an educational traffic simulator. And they thought about it for a while. They talked about it for a little while. And then they said, this is how this is going to work. It is essentially a simulator. It needs an orchestrator. It needs somebody in charge of the simulation. And we're going to use, in this particular case, the analogy of a cop to say there's a cop in charge of the traffic moving along. And so they talked about this and got to the heart of this design problem within the first 10 minutes of talking about it. Novices don't usually do that. And so the experts have a sense of setting aside all the things that are not important right now, because they know that if they actually solve all the things that are not important, it depends a lot on how they solve the part that is the essence. If they solve the essence in one way, all the peripheral things fall out in one way. If they solve the essence in another way, all of the peripheral stuff falls out in another way. And so they know that if they actually work on the peripheral stuff first, that might change, and thus it might be wasted effort. So they go to the hard part, and they're not afraid to actually address that hard part first, even if it means to spend significant time on it. Related to that is that experts go as deep as needed. And so one of the things that I often see in teams that are there but not quite there yet is they'll be at the whiteboard, they'll discuss, and they'll come to a solution, and they'll sit there and they go, that's good. We think that's going to work. Experts are never content that way, and they'll always go a little bit deeper, and they always want to prove to themselves that it really does work. And so one of the examples that I can use there is when you think about the Eclipse project. When Eclipse got built, or designed actually, it started out with 4 folks in a room. Room had a lot of whiteboards. They did a lot of discussion, but the room also had some computers. And those computers were essential because what did they do? They discussed the shape of their design, and then they went to implement the core parts of it. So they focused on the hard part, they focused on the essence, and then they said, let's prove to ourselves that this actually works. So they went much deeper than the whiteboard sketch or even the UML diagram. They actually went to code to demonstrate that their concept worked. And of course, some parts did, some parts didn't, which then caused them to go back to the whiteboard, adjust, and go through this particular cycle. So experts do go much deeper than the novice designer, which allows them, of course, to find problems much earlier, which then, of course, also allows them to correct those problems much earlier before other parts of the design start depending on it too much. And this also directly relates to experts generating alternatives. Many examples that I have of companies or student teams or design teams elsewhere where we come up with one solution and we're content with that solution. Expert software designers set themselves apart by actually thinking much more about multiple solutions. And so they mentally, or actually sometimes expressly so, will design a piece of software multiple times. And they'll say, we could do it this way, we could do it that way, we could do it that way. And then they'll actually look at the trade-offs amongst them, which usually leads to none of the alternatives being selected, but a new alternative emerging, which combines the best aspects of the ones that they've thought about. And this happens all the time. Often it will happen in the mind of the expert, much less so explicitly, but the alternatives are always there. They're always thinking about, how can I do this differently? Is that a better way? Is that a cheaper way? Is it a more elegant way? They're constantly thinking about how to do things differently. And that requires them to be very aware of what they're doing, right? To sort of step back and say, okay, I'm working on this, but were there other choices that I could have made? And they do this very explicitly. In their process, sort of insight number 4 for today, experts draw the problem as much as they draw the solution. And so here you again see the traffic simulator with on the left-hand side an informal diagram with some classes. On the right-hand side, though, is the design problem, is the understanding of what needs to happen when the traffic light switches. And so novice teams often forget to draw this part, whereas experts do draw this part and use it extensively because they're often mentally simulating with the diagram on the left, using the concrete scenario on the right, how does this actually work? And if we look at an example from real life, here's a whiteboard taken from a local healthcare company, and it has the pretty much unreadable diagram on the left. And if we look at that diagram and we try to guess what it might be, I bet you some of you may, but most of you won't, figure out that we're actually looking at a hospital. Okay, so the third label from the top says IC, which is the intensive care. The labels above that say patient room and patient room. And what they were working on was a piece of software where what they needed to do is they needed to schedule which patients moved from the IC, the intensive care, to which patient rooms. Now that might seem like a simple problem, but it's not, because certain diseases or certain conditions are not necessarily compatible. If somebody has an open wound and somebody else has an airborne infection, they probably should not be in the same room. And so what they were doing here is they were building their own understanding of how the algorithm, the allocation algorithm, should actually work. And so they used that diagram on the left for almost half the design meeting. That's where they were talking through all the scenarios, coming up with all the issues that might arise, internalizing the concerns that they have, and then slowly but surely transitioning into solution design. But again, while they were designing the solution, they would always go back to this diagram and say, okay, so how does that really work? So these problem diagrams are incredibly important in the navigation of the design problem. And in that process, what we also find is that experts will shift between formal and informal. We all know the role that informal design plays. I've already shown numerous whiteboards. Whiteboards are essential. It's where the hardest, the most important decisions often get made. They don't get made behind my UML editor. They get made as a team, usually at the whiteboard. But while we're doing that, one of the things that we see experts do is, again, not being quite content, just leaving the whiteboard to whiteboard. So here's a sequence of diagrams taken from, again, the local healthcare company, where they had a problem where they needed to optimize a database. And because the database was too slow in the particular middleware, they, on the top left, first worked at the whiteboard, designed it, Then one of the designers took it, built a UML diagram. They went back to the whiteboard to talk about that UML diagram. They then came back and drew more UML diagrams, in this case, sequence diagrams and collaboration diagrams, discovered some problems, went back to the informal sketches on the whiteboard, and then finally produced the more full UML diagrams. So experts know that neither one of these methods is sufficient, right? So they know that if they're going to work only with the UML diagrams, they can't quite do that as a team. It bogs them down. It's too slow. It's too tedious. It's too formal a notation. It doesn't promote much of the exploration that we like to do. Experts also know that the whiteboards are not enough either, because they often lead to, one would say, a false sense of security. We're there, we think it all works, and so it's the interaction between the informal and formal that is crucial to the expert, and they will make sure that it happens. Rather than just letting it happen by happenstance, they will make sure that it happens. So all those diagrams that they produce, what's interesting that experts keep them. They don't toss them, they keep them. They have stacks and stacks, or they have electronic photographs, or they have some archive of the design documents, the design diagrams, the notes, and everything else that they needed. And they will sometimes go back to them. And not that quick either sometimes. Sometimes it's the next day, sometimes it's the next year. But they have them, and they will return to them. And of course, the best illustration is any whiteboard in so many ways in any kind of company. And this is a whiteboard at a company called Hortonworks. And you can see that this whiteboard has been preserved. But what you can also, you can't quite see it, but what I know from observing is that many of these places on these whiteboards have been revisited. So teams have come back to their portion of the whiteboard, erased some parts that were not relevant, and revisited parts that were relevant. So they didn't have to recreate the context, they didn't have to recreate the diagrams, but they actually understood what was there and worked with them. And that leads to experts repeating activities. So experts always do things not once, but they do things twice. They do things 3 times. They do things sometimes 4 or 5 times. They do it in different kind of contexts. They do it with different kinds of people. And so one of the examples, again, the designer that I showed earlier on one of the early slides, he was tasked with redesigning a product line architecture. So he did all the things that one would expect. He would walk, he'd take showers, he'd make notes, worked by himself for a long time. But then what he would do, and this is just one example of repetition, is he would ask one of his colleagues and say, can you come to the whiteboard with me? And he would go to the whiteboard with the colleague and start explaining the design that he's been working on. Explain, explain, explain. And in the meantime, the colleague gives feedback. And then the designer says, okay, thank you. And the next day does the same thing with another designer. And the next day did the same thing with yet another designer. So why did they do that? Well, they did that because they knew that, of course, different people will have a different perspective. But they also know that in explaining their design, they often find some of the problems already themselves. And so they know that by doing this repeatedly, they wouldn't fall into the same trap each time. They also would get different kinds of feedback each time that they were then able to integrate. And then they would do this where they would actually take that feedback, enhance their design, and go through the process again, repeatedly. And that's what we see experts do. Experts will repeatedly test. Experts will repeatedly make another alternative, explicitly so. Experts will repeatedly ask the same question of a customer or a client or a user because they know they might get a different answer the next time they ask. And so repetition is something that is built into their habits and ways of working. Another way that repetition is built in is at a very fine-grained level. And so at this particularly fine-grained level, we're looking at experts rotating among subject pairs. And this one bears a little bit of explanation. So when we think about a design project like the traffic simulator, we have to think about light timing, we have to think about cars moving and directions where they go. We have to think about cars interacting with each other. If there's a car in front of me, I have to stop. We have to think about all these different kinds of aspects of the simulation. What experts will do is typically not focus on one of those in isolation, but they will take two of those and work on them at the same time. But they won't do it too long. They will take two of those for 5 minutes, and then they'll rotate to a couple of others for 7 minutes. And then they rotate to a couple of others for 2 minutes. And then they will rotate to a couple of others for 4 minutes. And they do this, and in this process, they shore up sort of all parts of the design that are important, kind of in parallel. And so if we look at the graphs that are here, promise is the only real academic graph that is in this particular talk. The top three are taken from dialogues and designs made by expert software designers. And the bottom three are taken by novice, from design sessions by novice designers. And so if we look at the bottom two in particular, we see these long black bars. And those long black bars meant these designers, these students in this particular case, grad students, were talking about one subject for a really long time. In one case, actually 1/3 of the design was essentially talking about this one subject the entire time. And essentially they were stuck, right? They were stuck, they were talking, they were trying to make progress, and so on and so on. And it's common for novice designers, novice teams, to do this because we got to sort this out. You look at the experts, the top three, we don't see such long bars. And we never see one bar by itself for that an extended period of time. They're always talking two subjects at the same time. So one dark bar and one light bar stacked above each other. And they rotate them very, very quickly. And this is not something that we believe the experts do by design, right? They're not designing, they're going, oh, 5 minutes is up. We now need to talk about something else. And then 2 minutes is up. We now got to talk about something else. It is an ingrained behavior that they've learned that they need to continuously look at all parts of the design to make sure that they keep pushing the design forward as they need to push it forward. So I'm going to do a couple more because I think I have about 10 to 15 minutes left. So let's look at this one, which is an interesting one, right? Experts see error as opportunity. Most people that I know are not so happy when they have a design problem or when they have a development problem, right? When the software fails, the software crashes, or when my design actually can't quite do something that I thought it was going to do. Experts, on the other hand, they see error as opportunity because it allows them a greater understanding in what they're trying to solve. And I think I could give no better example than Margaret Hamilton, who gave the keynote at ICSI this particular year in May in Sweden. And she talked about what would happen when they would find an error in their simulation, because clearly they were designing the software that would go up in space. And once it was launched, it was going to run. And so she was actually extremely happy if they found a mistake on the ground during testing or simulation, because that is one fewer mistake that goes up when we launch. But more deeply so, what each error that she found allowed her to do is conceptualize why this might be happening, right? So it's not, it's a mistake, it's a problem, I'm going to fix it. It is, it's a mistake, it's a problem. Was it something wrong with my thinking? Is there an assumption that I'm making that is not right? Is there a constraint that we're violating? And so rather than having the mentality of quickly, let's fix it, it is much more so about understanding and fixing it right. And so experts see this error as opportunity to really improve their design rather than, quickly fix it, as I said earlier. And in that light, experts will often play the fool. So experts will put on the hat of, so what happens when somebody presses this button? Or what happens if somebody doesn't do this? Or what happens if, heaven forbid, the internet goes out tomorrow, right? How will our software stay working? And so they're not afraid to place themselves in the shoes of components of the design that might not function properly, in the shoes of users who might not behave properly, in the shoes of the infrastructure which might not provide what we believe it might provide. So they will examine the design, not just from the optimistic, here's how it's all going to work angle, but they're actually going to design it and look at it from the what all can go wrong as well. And then in that process, they're extremely alert to evidence that challenges their theory. So they will look for things that don't quite align, right? And so we have stories of designers who would go shadow some users because we needed to understand more what they did, and shadow the users and their work practices. And there's clearly defined work practices. It is, here's what you do, and then they're looking at the user, and the user is supposed to press one of the function keys to generate a report, but instead does a whole bunch of other things to generate the report. The expert will not say, okay, they got the report, it's okay. They'll say, why did you not go about it the way that you went about it? And then one of the interesting answers that I've seen happen is, well, if I press that, the software crashes. Or if I press that, it has this particular side effect. And those are exactly the kinds of things that an expert needs to know in order to design the next version of the system. If we're not alert to what is different from what our conceptual mindset is, we're not going to design the right piece of software. So as I said, I have a couple more, then we'll be done. Here is an important one, which is experts curtail digressions. We've all been in design meetings where what happens is we're designing, we get into the heat of it, and before we know it, 45 minutes passes, and then somebody says, are we still solving the problem? Are we actually getting somewhere? And the answer is, well, maybe not. And so experts, in this particular case, the caricature is, we're focusing on the architecture. We don't need to design the font. Experts will put this into practice during their meetings. And so here's an example where, again, it's from a local healthcare company. On the left side, you see little check marks, little stars and little circles, where the first thing that we did was we focused the meeting. We said, these are the kinds of things that we need to be talking about. We made that explicit on the particular whiteboard. And we said, let's go now design. And the expert would then periodically circle back to that list and say, let's focus. Are we doing this one? Are we doing that one? And so not allowing us to digress into other considerations that are also important, but not necessarily important for this particular meeting. One of the interesting things that does happen then in these kinds of meetings is that experts agree to disagree. And this is probably one of the sources that allows experts to move through a design problem more quickly than teams of novices. Because as soon as there's a disagreement in a team of novices, often what we see is they get stuck. They want to resolve this particular conflict. Well, experts actually know to disagree. And here's an interesting example where there's a different pair of designers also working on the traffic light simulator. They were fabulous. On the left-hand side, we see one person who did most of the design on the board. The other person sat down but provided lots of her input. And at some point, the person got up and actually drew the little car on the bottom left of that whiteboard. And that was the most important thing that got drawn on that whiteboard the entire session, because it showed a fundamental disagreement between the designer on the left, who said, I believe we only need to model how busy roads are. We don't need to model cars explicitly. And she said, actually, we do. We really do need to model these cars. And they argued about it for a little while. And then they said, okay, it's all right. We'll disagree. We're going to design some other parts of the software, some other parts of the system, and maybe, just maybe, designing those other parts will give us information about our decision that we need to make. And sure enough, they disagreed. They designed some other parts, and it clearly told them that cars need to be modeled. They didn't have to argue about it. It became clear. And that's exactly what happened with the person on the left. He said at some point, yes, you're right. Cars need to actually be modeled. We need to get them in here, so let's get going. And so that story is extremely powerful, right? So understanding that there are multiple paths, understanding that we don't have to resolve them right now, and understanding that there's other parts of the design that actually will help us clarify what we're trying to do is an important practice that we see experts put into play all the time. So experts will use design methods. I think many of us are familiar with design methods from the various many books that actually exist. Experts will use them, but they'll use them selectively. They'll use them when they need them, but they won't necessarily use them all the time, as in this is the method by which we will always get the right answer. So if they feel they're stuck, if they feel they need to do something, they will pull out a design method. So they might, in this particular case, design some personas. Or they might, in this particular case, really understand clusters of different users. And again, this is taken from, in this particular case, an interaction design company, where they spend a few days actually really trying to understand the different users that are there. Even though on the surface, the design problems seem to have a pretty homogeneous set of users, what the designer, when I said earlier, the designers alert to evidence that challenges their theory. When the designers started to talk to some of them, they started to get a hunch that maybe they're not quite so. And that's when they said, all right, maybe, maybe not. We can either make an assumption that they are and be horribly wrong, or we can actually use one of these design methods where what we're going to do is interview a bunch of people, build personas, and see whether our assumption holds or not. And so the designer said, well, clearly we can't make faulty assumptions, so let's use this design method at this moment in time. And what came out was, indeed, that about 50% was homogeneous, but the other 50% was not, and that heavily influenced their particular design problem. And so their particular design solution. So the designers were clearly aware of what they needed to do to overcome a potential problem in their design approach. And they will borrow, in this particular case, a design method to make that work. And then, last but not least, experts will socially embed and reinforce good practice. So experts are aware that a high-functioning team requires everybody to be aware of the kinds of things that we've talked about, right? It requires everybody to explore alternatives. It requires everybody to be respectful of each other. It requires everybody to listen to the opinions of others. It requires everybody to iterate. And so experts will socially embed and reinforce this good practice, and particularly actually will focus a lot on the novice, the newbies, and educate them and tell them why we're going about things in a certain way. So that's the last one that I'll talk about. But I do want to wrap it up a little bit by saying, okay, so what does all this really mean? Well, first let's talk about just the limitations of what I've talked about. So the set of 66 insights is surely not complete. At this point, it is ones, though, that we know exist. It's ones that we have verified either ourselves or through literature, i.e. studies of others. There's always empirical evidence of designs and experts and teams and individuals where it's been documented that this is making a difference and this is what they do. So, but there's clearly others, and there's room for more study in that regard. Applying the insights does not guarantee success, right? It's not that you're going to show up at a design meeting and say, let's build 3 alternatives and spend 10 minutes doing alternatives and now have a successful design. Design is still very much contextualized. You need to know when you want to apply the insights, when is the right time to step in to do something. So it's not an automatic that success is there. You still need to team, you still need the understanding of the problem, you still need to have the right context to get there. And then reading the book, however brief it is, does not turn one into an expert software designer overnight. And the key insight there is, it's not necessarily whether you're aware of it, it's actually whether you practice it, right? So one of the things that we often get is people say, well, keep it simple, we know that. And then we see a designer actually designing, and they're designing the most complex thing, where there's a much more simple approach. So it's actually about putting them into practice and being conscious about them, and then actually practicing that a whole lot, because design is as much experience and expertise over time as it is knowing how to behave. So the benefits about these insights, though, is that the book offers a vocabulary for talking design. And so one of the examples that we're now working on, or one of the projects that we're now working on, is we're working with Mozilla to talk about their design process and to work with them to understand how their designers can improve themselves and can actually instill a culture of design in the organization. And so the book gives a vocabulary of talking about it, right? We didn't design alternatives, or we didn't really draw the design problem as much as we probably should have. And that led to this particular problem that we had. So it offers a vocabulary for talking design. And then it also, of course, offers the opportunity for reflection upon one's own practices and the teams and organizational practices. So it's key to building this design capacity. And that is sort of the real big lesson that's here is not so much to what degree you're aware of these insights and practices, right, and habits. Do you actually practice them, and do you practice them consciously? And that is the big question. Can you take some of these lessons and put them in your design meeting? And could you say, did we actually design enough alternatives? Or did we clarify all the assumptions? Or did we do enough borrowing of ideas from other places? Are we not trying to do too much greenfield design in a place where we know that we don't have to, right? So can you actually step out of the design meeting? The internal joke that Marion and I have is that expert software designers really are in the room twice. So they're there, fully participating in the design, arguing positions, clarifying assumptions, setting constraints, making progress, contributing ideas. But they're also in the room another time. They're standing in the back of the room and they're observing the team working. They're looking at what they're doing, and they're reflecting on whether this is a good way about going about the design project and whether we're actually using the right approaches and the right strategies and the right way of talking to each other. And so experts move back and forth between those roles, but they certainly do this very, very consciously. And so that's the big challenge that I would like to put in front of all the readership or listenership in this particular case, as I put in front of my undergraduate students when I teach now this kind of material is, can you take one of these lessons and put them in your next design meeting? Or can you take another one and put them in one of the other meetings that you have the next time around? Because that's how you are going to be able to advance yourself and the team to hopefully build better designs in future. And so with that, I think we're pretty much at the end of the talk, although I believe there's time for question and answer. So for those of you who ride bicycles, keep on riding. It keeps me happy just as much as it keeps me happy thinking about software design and how to reflect on what designers do and hopefully educate the next generation to be better designers yet. And so thank you to all the designers that have allowed us to study them. And that concludes my talk.
Thank you, André. However, I think I won't think about design when I'm riding my bike. It's dangerous enough when I'm on a bike anyway. Our first question then. Our first question is, I've got a number here. I should have said that, sorry. They've been coming in quite quickly. How does a team differentiate between a design issue and an implementation issue?
That's a great question. So it depends a little bit what point of view you take as what is design. Okay? There certainly is a group of folks who believe that you can do design, hand it off to an implementation team, and let them build it within all of the constraints and decisions that have been made. In those cases, design is really making all the decisions for everybody else, and then everybody else sort of executing them. I personally don't believe in that particular view. I actually believe that every person on a software development team in the end is a software designer, partly because we actually have to make decisions as programmers that well can change the experience of the users, right? We could use the wrong sorting algorithm. I've seen that happen. We could produce the wrong report, even though it was pretty clear. I've seen that happen. So in terms of what's design and what's implementation, anything that is really dramatically going to influence the shape of the solution and how well it works for the customers or the users, the clients, that I would actually label under design. And those who are programming, you're still making smaller design decisions, right? That's why we run to the whiteboard and grab somebody there. And so I actually find it very hard to distinguish between them, other than they're sort of different gradations of design, right? There's sorting out the core of how this thing works, and then there's many peripheral design decisions. But those peripheral decisions are still equally important.
Thanks very much. I've got quite a lot of questions here, so I'm going to try and cover as many of them as I possibly can within the time available. An interesting one here, if I can raise it with you, which is there a model diagram to visualize design thinking as a practice? That would be a meta diagram, I suppose.
Oof, I don't think there is one at this moment in time. I'll take that up as a challenge. So whoever asked the question is more than welcome to email me the question. I don't think that at this moment there is such a thing. I think there's attempts at making it happen, but it's not there yet.
I think I would agree with that. Well, I have another question here, just to keep them coming at you, André. Quite a nice one, which says, is this approach compatible with agile development, the idea of creating a working version first? And in fact, I should say at this point, there's 2 or 3 questions around agile, and I thought this one focused them quite nicely, actually.
I think 100% so. I think what we've presented is in many ways not a methodology, right? It's not a here's the steps you all take to actually get to the outcome. What we've presented is a bunch of things that we know expert designers do when they're working. It doesn't kind of matter what context they're working in, right? It doesn't matter if they're working in a let's say Boeing, where they have to eventually produce a very formal document. The thinking process and how they engage in their thinking and how they engage in navigating the difficult design problem, that's important. And that doesn't go away. Whether we're doing agile or waterfall or spiral, we still have to solve the problem and we still have to deeply think about it. What agile gives us is sort of a shorter cycle in that. But again, it doesn't take away that we need to design some sort of architecture that can withstand the changes that are happening. And that doesn't mean that when the next iteration comes by, the next sprint comes by, we don't need to go to the whiteboard and actually design some parts of it. And so what's in the book is very compatible. It's really about human behavior and team behavior.
Thanks. Right, on to another one, which says, what do experts do to try to minimize the number of mistakes in the design phase?
Great question. And actually, that is a chapter in the book. So experts test. They will continuously challenge themselves. So that they will both sort of explicitly walk through their design time and time again, essentially mentally simulating. And if they cannot mentally simulate, they will simulate it with the help of diagrams on the board. There's numerous pictures we have of a designer standing in front of the whiteboard where you have one hand pointing to one diagram and another hand pointing to another diagram, and clearly they're walking through step by step to keep these partial diagrams in sync. And in some ways, all of what I've talked about is about minimizing mistakes, right? It's about pulling in the collaborator who knows a little bit about this particular aspect of the design. It's looking at existing designs in the real world and what they look like. It's building the code like what the Eclipse folks did and actually running it. And so almost all of the practices are geared at designing a high quality design that stands up in the long run. And so it's not that I can point to any one of them, other than that I see experts always simulating the design. They always are thinking about how it works, no matter where they are.
Fine. Oh, here's a slightly different one. It says, in your study, what was more important for expert designers? A, correctness of the design, or B, its performance?
I'm going to take a really liberal correctness approach. So the main thing that they care about is that it works, and that it works under the constraints and goals that are there. So if there's a design, if there's a problem where performance is really important, right? It is the performance of my cloud infrastructure, or it's the performance of the retrieval of the images for Facebook so that I get my Facebook page a little quicker. Then, of course, performance becomes important, but they're still focused on, did I solve the problem, and did I solve it right? Because in the end, they're acutely aware that these small things that might not be 100% correct often will come back to bite them in future. And so they sort of don't choose between the two. If performance is important, it becomes part of the overall picture of quality, and they want an elegant solution for the problem that they've been given.
Fine. Well, thank you very much indeed, André. I'm afraid we've run out of time today, and apologies to those whose questions I couldn't put forward. I'd like to thank André again for his informative presentation and the insightful answers to the many questions. And special thanks to each of you for taking the time to attend and participate in today's webinar. This webinar was recorded and it will be available online in a few days at, I'll read it out in full, http://www.sigsoft.org/resources/webinars.html. And you can find announcements on upcoming ACM and Sigsoft webinars and other ACM activities at learning.acm.org and www.sigsoft.org. So finally, on behalf of Sigsoft, the speakers and myself, thanks again for joining us, and I hope you'll join us again in the future. And this concludes today's webinar. Thank you very much.